So we've got our cobalt and iron reaction that we saw earlier on. We're going to balance that one. It was Fe3 plus aqueous plus CO as a solid in equilibrium with Fe2 plus CO2 plus. Both of those are aqueous. So our job is to balance this using the half reaction method. So we have to find out what's reduced, write its half reaction, write out what's oxidized, write its half reaction, and then balance them across. I'm always just in the habit of writing reduced first, I guess probably because my instructors did it that way. But the reduction half reaction, which one of these get reduced? Iron goes from 3 plus to 2 plus. Cobalt goes from 0 to plus 2. So cobalt goes from 0 to plus 2, that's an increase in the oxidation number, that's oxidation. 3 plus for iron going to 2 plus, that's your reduction. So Fe3 plus 1 electron in equilibrium with Fe2 plus. Both of those ions are aqueous. That's our reduction half reaction. And we write the same kind of thing for the oxidation part. Cobalt's being oxidized from 0 to 2 plus. So the first thing we do, once we get our half reactions written, is balance the electrons. Okay? So to balance the electrons, we have to take the iron reaction and do that one twice. We can't just change this to a 2 electron and this to a 2 and this to a 2. We look at the electrons first. That's the process. Okay? So, and we also can't just change this to a 2 because we want the electrons to balance. They have to be mass and charge balanced. Okay, so we take this reaction now, we multiply it through by 2. And it's totally fine if you want to rewrite them. So we bring that 2 and carry it through. So 2 Fe3 plus now 2 electrons in equilibrium with Fe2 plus, and there's 2 of those now. So this is red. The ox didn't change. Sometimes they'll both change. If there's 3 electrons in one process and 2 in the other, they both have to be multiplied. But in this case, oxidation doesn't change. Because we wanted to make 2 electrons, because we have to consume 2. So now the electrons cancel, and we write what's left over as our balanced electrochemical reaction. 2 Fe3 plus CO as a solid, making 2 Fe2 pluses, aqueous, plus CO2 plus, aqueous. There's our balanced half reaction for that reaction. Okay? And again, it doesn't matter which order you put the iron and cobalt on each side, as long as the charges are right and they're on the correct sides of the arrow, you're good to go. All right, we're going to try one more that we haven't seen already as a reaction. Slide that one out of the way. Here's your reaction. Al is a solid, plus Ag plus, aqueous, in equilibrium with Al3 plus, aqueous, plus Ag as a solid. Now what I'd like you to do here is to pause the video and solve it. And then hit play again and see if your stuff matches mine. Okay, so pause. All right, so we're going to work through this one the same way we did the others with our half reactions. We need the reduction and the oxidation parts. So when I look at this, I see Ag1 plus going to Ag0. Remember, all of the elements are zeros. There's your reduction. Silver is being reduced. It goes from +1 to 0. That's a 1 electron reduction. So when we write this, we need to include +1 electron on the left-hand side. to make our Ag solid. There's our reduction half reaction before balancing across the two. Now in oxidation, Al goes from 0 to 3 plus. That's a 3 electron oxidation. So Al as a solid makes Al 3 plus 3 electrons. So we have individual half reactions. Now we have to balance the pair. And the way we balance the pair is that the number of electrons has to match. So we need to take the silver one and do that one 3 times because we have to use up 3 electrons. So if you rewrite it, that's fine. If when you're doing these, you want to leave some space in between here so you can rewrite one below, that's fine. I'm just going to rewrite both underneath here. So red now becomes 3 Ag plus 3 electrons, making 3 Ags as a solid. And ox now is the same. Al as a solid, making Al 3 plus aqueous plus 3 electrons. Now we have mass balanced and charge balanced half reactions. The electrons had better match at this point, so they cancel, and you just write down the rest. So the overall balanced reaction is 3 Ag pluses plus Al as a solid, making Al 3 plus aqueous plus 3 Ags as a solid. So there's your overall balanced reaction. The half reaction method works the same now as it did last semester, but it's more streamlined here because there are no other atoms involved. We have just our metal ions. And so we don't have to worry about all those water molecules and OH groups and stuff that we did last semester. So I hope that given these 3 examples, you can pretty much do any of these that you come across. You got to be careful with the number of electrons you've got. They have to match each other. Like I said, sometimes you'll have a 3 and a 2, in which case you'll be multiplying both of the half reactions by something in order to make them match in the balanced part down here. Okay? Good luck, folks.